Hello students, welcome to video classes. So according to the schedule, today we are going to discuss about the ray optics. Okay, let us solve the problems. As usual, I already told you many times, when I am going to show you the problem on the screen, just keep the video on pause and read the problem very carefully and then continue for the solution. Okay, let us start the problems. Welcome back students. I hope all of you read the problem. So the problem is saying that the two mirrors are there. They are going to be inclined by 60 degrees angle and a ray of light is going to be incident on the first mirror in such a way that it should be parallel to the second mirror. And you have to find out that how it will be travels after reflection from the second mirror. Okay, after reflection from the second mirror, how it will be travels, you have to explain. So there the options are given. Let us draw the diagram. It will help you to understand what is going to be happens. So let us say the two mirrors you are taking, this is the one plane mirror, it is in horizontal direction, and another mirror you are going to be taking in this direction. Let us say that this is the another mirror and this is the horizontal mirror, and the angle is given as 60 degrees. How much angle is given? 60 degrees it is given. And a ray of light is going to be incident on the first mirror. Let us say that this is M1 and this is M2. Okay, M1 and M2. So a ray of light is going to be incident parallel to the second mirror, like this. It is going to be incidenting, which is exactly parallel to the second mirror. If it is parallel to the second mirror, definitely what is the angle here? It is also 60 degrees will be takes place. If it is a 60 degrees, then immediately what happens? It will be reflects. It will be reflects and it is going to be incident on the second mirror. Okay, it is going to be incident on the second mirror. So the ray of light is traveling in this direction. Okay, then if it is the angle 60 degrees, then what is this angle is also? Definitely this angle is also equals to 60 degrees, because in the reflection the angles will be remain same. So this is a triangle you are going to be having here. If I am going to refer to this triangle, this is 60 degrees plus this 60 degrees. No doubt this angle is also equals to 60 degrees. Okay, that angle is also equals to 60 degrees. Okay, now when you are going to refer to this 60 degrees, after reflection what happened? It will be travels in this direction. After reflection, it will be traveling in this direction. Okay, so this ray is going to be reflecting here. If this ray is reflecting here, then what happened? How much angle is there here? The same angle will be takes place at this point also. So that's why this is also equals to 60 degrees. Okay, that is also equals to 60 degrees. Then if it is also equals to 60 degrees, then what you are understanding here? Whatever the ray is going to be reflecting here, this ray is parallel to the incident, parallel to the first mirror. Okay, so this diagram will clearly express that whatever the ray is reflected from the second mirror is parallel to the first mirror. So that means which option will be correct here? The second option, parallel to the first mirror. Okay, so what is happening here? The incident ray is parallel to the second mirror. After reflecting here, it is going to be incident on the second mirror. After reflection from the second mirror, again it is parallel to the first mirror. Okay, like that you have to find out. Okay, let's go for the next problem. Hello students, welcome back. So in the problem, the two mirrors are given. He is saying that left side mirror and the right side mirror. The distance between them is given 3 meters and a person is standing at a distance of 1 meter from the right side mirror. And you have to find out that what is the second nearest image produced in the right side mirror, you have to find out. Okay, so let us draw the diagram here. This is the plane surface you are taking. Okay, this is the plane surface. And you are going to take the two mirrors here. This is the first mirror you are taking and this is the second mirror. Okay, first mirror and the second mirror you are taking. So the mirrors are going to be arranged like this. They are facing each other. And a person is standing here. Okay, a person is standing here. at what distance? 1 meter, and this distance will be 2 meters. Let us say that this is L1 and this is L2. Okay, this is the right side mirror and this is the left side mirror. Okay, this is the right side mirror and this is the left side mirror. And what you have to find out, you have to find out what is the second nearest image produced in the right side mirror. So right side mirror, let us see that first we can take the first image is going to be produced by the image of this person will be produced by the right side image. Where it is going to produce? Exactly, it is going to produce at this point. Okay, it is going to be produced at this point, and this is called the image 1. Okay, what it is called? The image 1. And at what distance it will be? 1 meter. Because the person is at the 1 meter distance, then the image is going to be produced at the first meter distance. Now, next what happened? This image will becomes object for this one. Okay, this image will becomes object for this one, and where it is going to be produces. And second mirror is asking, no, second mirror means what happens here? First what happened? This mirror produces the object image. Okay, this object is there. This object will be second mirror, and the image of this object will be produced on the left side. Exactly at what distance it will be produces? Okay, at a distance of 2 meters. Okay, this is the image 2. Okay, first image is produced by the first mirror. This image 2 is produced by the second mirror. Now what happens here? This mirror will going to produce the second image. Okay, this mirror will produce a second image. Then what happened? This image 2 will becomes object for this mirror. Okay, this image 2 will becomes object for this mirror, and it is going to produce as the image. And let us say that if you are going to extend this one, then from this mirror, where is the object distance will be? Up to here it is 5, and this is 3 plus 2, 5 meters. That means this image 2 is exactly at a distance of 5 meters from the first mirror. Then the image of this will be forms behind the right side mirror. At what distance? 5 meters distance it will produces. 5 meters distance means it is going to take place at here. The image is going to be produced, and this is the image 3, and it is exactly at a distance of how much? 5 meters. Okay, this image is going to be produced exactly at a distance of 5 meters. But in the problem, what is asking? What is the nearest image, second image, nearest second image from the right mirror? From where is asking? From the observer is asking. So this is the first image and this is the second image. The second image is exactly at the distance of 5 meters, and from this is 1 meter. So totally how much distance will be there? It will be 6 meters distance. That means the second nearest image is going to be produced exactly at a distance of 6 meters from the object. If I find out the second nearest image in the left side mirror, then again what happened? This image 3 will becomes object for this, and it is going to be produced as beside this. Then what happened? This total distance will be up to here it is 3 plus 5, 8. That means it is going to be formed at 8 meters distance behind the mirror. This 8 meters plus 2, 10 meters. That means the second nearest image in the left side mirror will be 10 meters. Like that, you have to find out the answers itself. Okay, this type of problems are also very important for competitive. Let's go for the next problem. Welcome back, students. So in the problem is saying that an object is initially at the distance of 100 centimeters. So this time the object is not moving, the mirror is moving towards the object with a velocity of is given 5 centimeter per second, and after 6 seconds what is the distance between the image and the object you have to find out. So just let us draw a small diagram that will help you to solve the problem. So this is the horizontal ground, and let us say that this is the mirror is here. Okay, this is the mirror. And let us say that an object is at here, or a person is standing at here. So initially the distance is 100 centimeters. Okay, the distance is given as 100 centimeters. Now the mirror is moving towards in this direction with 5 centimeter per second. It is moving with 5 centimeter per second. After 6 seconds, what happened? Let us say that the object mirror is going to be reach up to this point. Okay, the mirror is going to reach up to this point. Okay, then you have to find out this distance x. Okay, if you can find out this distance x, how much distance it is moved, then it will be very easy to find out what is the distance between the image and the object. So to find out this distance, we need to find out that how much distance it is traveled in the 6 seconds. Then the general formula is that distance is equals to velocity into time. Okay, distance is equals to velocity into time. That is equals to, with what velocity it is traveling, 5 centimeter per second, into how much time it is traveled, 6 seconds. So that is equals to, it is 30 centimeters. That means x is equals to 30 centimeters. That means in 5 seconds, the mirror is going to travel 30 centimeters towards the object or towards the observer. Then what is this distance will remains? Okay, this is 100 and this is 30. 100 minus 30, how much you are going to get? 70 centimeters. That means after 6 seconds, the object is exactly at a distance of 70 centimeters. Okay, at a distance of 70 centimeters from the mirror. Then where the image will form? Exactly 70 centimeters behind it. So what is the distance between the image and the object? The distance between the image and the object is equals to 70 plus 70. That is equals to 140 centimeters. This is the answer itself. Okay, that means the distance between the image and the object. So the image is going to be produced right here. Okay, which is exactly at a distance of again 70 centimeters. So the distance between the object and the image, that is equals to 70 plus 70. How much you are going to get? 140 centimeters. So the which option is correct here? The second option is correct. Okay, 140 centimeters. Okay, let's go for the next problem. Hello, welcome back students. So in the problem there is a concave mirror is given and a square shape of the object of 1 millimeter size is going to be placed in front of the mirror at a distance of 15 centimeters it is given. And we have to find out what is the perimeter of the object or the image. Okay, perimeter of the image, that means the circumference of the image we have to find out. Okay, let us draw the diagram here. Let's say that this is the principal axis we are taking. And this is a concave mirror. Okay, this is the concave mirror. And what is the focal length is given to you? The focal length is given, f is equals to 10 centimeters it is given. And an object is going to be placed which is in the shape of the square shape. The square shape object is placed and the dimensions are given as A, it is B, it is C and it is D, which is exactly at a distance of 15 centimeters. Okay, you have to find out the 15 centimeters. So the object is at a distance of 15 centimeters. Now we have to find out the image distance. Once we can find out the image distance, then we have to find out what is the size. Okay, size perpendicular to the principal axis and size parallel to the principal axis. If you find out them, then it becomes very easy to find out the circumference. Let us find out that what is the image distance here. Object is at a distance of 15 centimeters. That means the image distance we have to find out. So to find out the image distance, we are going to use the formula 1 by f is equals to 1 by v minus 1 by e. Okay, mirror equation we are going to use. So when I am going to use the mirror equation, the equation is 1 by f is equals to 1 by v plus 1 by u. 1 by v plus 1 by u. Focal length, concave length will be minus, you have to take, and the object distance always you have to take minus. That means we have to find out 1 by v. 1 by v is equals to what we can write? 1 by f minus, it can be written as 1 by u is going to that side, it becomes minus 1 by u. Okay, so now let us substitute the values. That is equals to 1 by f means what I can write? Minus 1 by 10. Object distance is minus into minus will becomes plus 1 by 15. Okay, so that implies 1 by v is equals to 150 will be taken as LCM. 150 will be taken as LCM here. Then what happens? It will be 15 into 10 into. So what I am going to multiply with 15 here minus 15 and plus 10. That is equals to, it becomes minus 5 by 150. That implies V is equals to minus 150 by 5. Minus 150 by 5, that is nothing but minus 30 centimeters. If I am going to cancel it, you are going to get 30 centimeters. So that means the image distance V is equals to minus 30 centimeters you are calculating. Okay. So that means the image is going to be produced at a distance of 30 centimeters. Once you know the object distance and the image distance, then it will become very easy to find out the magnification. That magnification will give you that what is the height of the object perpendicular to the principal axis and parallel to the principal axis. So now we have to find out what is the magnification here. So to find out the magnification M is equals to, what is the formula? Minus V by U. Magnification M is equals to formula minus V by U. That is equals to V value, how much it is at 30 centimeters. Okay, minus 30 centimeters by object distance minus 15 centimeters. Okay, if I am going to simplify it, how much I am going to get? Minus 2 centimeters. Magnification is minus 2 centimeters you are going to have. Okay, if you are going to have the magnification, then it will be very easy to find out the height itself. So the image distance or the object distance. Okay, CD is the height of the object. C dash D dash, height of the image. A dash B dash, height of the image. So we know that the magnification is equals to height of the image by the height of the object. Then what is the formula? Height of the image is equals to height of the object into magnification. That means what you can write, you can write as B dash C dash is equals to, sorry, not B dash C dash, it will be A dash B dash. Okay, A dash B dash is equals to C dash D dash. C dash D dash is equals to magnification into height of the object. This is the height of the image because both are same size. So height of the image is equals to magnification into height of the object. That is equals to 2 into height of the object. Height of the object, how much it is given? 1 millimeter. That is equals to 2 into 1. How much I am going to get? 2 millimeters. That means the height of the image C dash D dash and B dash A dash both are equals to 2 millimeters we have calculated. Okay, one part we have completed. Next part we have to find out what is the lateral magnification. Lateral magnification means we are going to find out what is the magnification along the principal axis. If you want to find out the along the principal axis means what you can write? B dash C dash is equals to A dash D dash is equals to, the formula is V by U whole square. Okay, V by U whole square. This is the formula you need to remember. Okay, along the vertical to the perpendicular to the principal axis, V by U you can take. Along the parallel to the principal axis, you can take V by U whole square. V by U whole square means it is nothing but 30 by 15. It is minus and minus, it will be whole square, and you are going to get a negative sign again, same. Okay, so 30 by 2, that means 2 square. 2 square means it will be 4. Okay, you are going to get the 4. This magnification is equals to 4. Or 4, directly you are finding the magnification now, that is equals to into what you can write? Multiply with 1 millimeter, that is equals to, you are going to have the 4 millimeter. Okay, B dash C dash by BC, A dash D dash by AD is equals to, you are going to get 4. If you are going to directly calculating the magnification here, directly calculating the size of the image here, that's why you are going to multiply with 1, that is equals 4 millimeters. Now it is clear that what is happening here, this size, earlier it is 1 millimeter, after the image size will be 2 millimeters. This size, earlier it is 1 millimeter, now it is 4 millimeters. That means, what is the total parameter means? It is 2 plus 2, 4 plus 4. That means the total length of the image. Okay, total length of the image is equals to 2 plus 4 plus 4. Okay, 4 plus 4, 8, 8 plus 4, that is equals to 12 millimeters. This is the image size will be text, or the parameter of the image, 12 millimeters. So, okay, remember very carefully, first you have to find out the magnification perpendicular to the principal axis, magnification parallel to the principal axis. Based on that, you have to find out the size of the images and you are going to add them. Okay, the problem is very important, concentrate here. Let's go for the next problem.